Last time we talked about the tangent ratio and how we can use the tangent ratio to find the lengths of sides in a right triangle. Today we're going to be continuing our study in trigonometry. Tangent was one of the ratios in trigonometry, and today we're going to be talking about the sine and the cosine ratios. So with the sine ratio, we are still working with a right triangle. Let's call it triangle ABC. And we're still looking at an acute angle A. Now the sine of angle A, which we simply write as, it looks like sin A, but we say it, sine of A, is going to be the ratio of the length of the opposite leg divided by the length of the hypotenuse. In this triangle, which we saw last time, we are looking at side BC, which is opposite angle A, and the hypotenuse, which is opposite the right angle. So take a look at example 1. Find sine of S and sine of R. Write each answer as a fraction and as a decimal, rounded to 4 places. So sine of S, we're looking at angle S up on top there. We want to find the side that is opposite angle S. In this case, that would be RT. And the hypotenuse is the one across from the 90-degree angle. That would be SR. So sine of S is equal to RT over SR, which is equal to 63 over 65. So that's the answer as a fraction. And it also said to write it as a decimal rounded to 4 places. That would be 0.9692. Next, to find sine of R, this is the leg that is opposite angle R divided by the hypotenuse. So now look at everything in terms of angle R. The leg that is opposite angle R is ST, and the hypotenuse is across from the 90-degree angle, and that would be SR. So this is equal to ST over SR, which is equal to 16 over 65, and rounding that, we get this is around 0.2462. Let's look at an example where we use a sine ratio to find the measure of one of the sides in a triangle. So here it says use a sine ratio to find the value of x. Let's look at everything we have. We have this 51-degree angle. We have the side that's opposite the 51-degree angle, which is 14. And we're trying to solve for x, which is the hypotenuse, as it is across from the 90-degree angle. So to write a ratio using sine, this would be sine of 51 is equal to the opposite leg over the hypotenuse, and substituting, we have 14 over x. Now to solve for x, I'm going to multiply both sides by x, and then I'm going to divide both sides by sine of 51. So 14 divided by sine of 51, just like with tangent, you want to make sure that your calculator is in degree mode. So 14 over sine of 51 comes out to be about 14 over 0.777, which is about 18.01. So those are examples using the sine ratio. Now let's talk about the cosine ratio. So with the cosine ratio, we are again going to look at the right triangle, triangle ABC with acute angle A. Now the cosine of angle A, which we write as just COSA, it looks like cos A, but we are going to read it as cosine of A, is defined as cosine of A equals the length of the adjacent leg to angle A divided by the hypotenuse. So this is AC over AB if we're looking at this triangle here. So in relation to angle A, we're looking at the blue leg, the one that's adjacent to that angle, and dividing it by the hypotenuse. Now take a look at example 3. Find cosine of U and cosine of W. Write each answer as a fraction and as a decimal. So cosine of U is equal to the leg that is adjacent to angle U, that would be UV, divided by the hypotenuse, that would be UW. So this would be equal to 18 over 30, which is equal to 3 over 5. Now as a decimal, that would be 0.6. Now to find cosine of W, that would be the leg that is adjacent to angle W over the hypotenuse. So the leg that is adjacent to angle W is WV, and the hypotenuse is UW. So this is equal to 24 over 30, which is equal to 4 over 5, which is equal to 0.8. Take a look at example 4. This time we're going to use a cosine ratio to find the length of one of the sides in a right triangle. So here we have a 59-degree angle. We're given the leg that is adjacent to that 59-degree angle, that's 34, and we have the hypotenuse that we're trying to solve for, that's x. So cosine of 59 is equal to the adjacent leg over the hypotenuse, which in this case is 34 over x. Solving for x, we multiply both sides by x and divide both sides by cosine of 59. Cosine of 59, again, you'll want to make sure your calculator is in degree mode. If it has been in degree mode this time, then you should be in good shape. It won't revert back to radian mode unless you reset your calculator. So 34 divided by about 0.5150, which comes out to be about 66.01. Alright, example 5. You want to string a cable to make a dog run from two corners of a building, as shown in the diagram. Write and solve a proportion using a trigonometric ratio to approximate the length of cable you will need. So you see here we have a right triangle. We have the 35-degree angle there. And then you want to look and see what other information you're given. In terms of the sides, you have the hypotenuse, and you have the leg that is opposite the 35-degree angle. So based on that information, you want to use the trigonometric ratio that uses the opposite leg and the hypotenuse. In this case, that would be sine. So sine of 35 degrees is equal to the opposite leg over the hypotenuse. Substituting, we have sine of 35 is equal to 11 over x. And then we want to multiply both sides by x so that we can eventually get x by itself. So now we can divide both sides by sine of 35. And 11 divided by sine of 35 is equal to 11 divided by 0.5736, which comes out to be about 19.2. So you're going to need a little bit more than 19 feet of cable. Now, a lot of the times in word problems involving sine, cosine, and even tangent, you're going to be talking about what we call angles of elevation and depression. Now, what this tells you is some angle measure in the situation. Now, if you are looking up at an object, the angle your line of sight makes with the horizontal is called the angle of elevation. And you can see this down here with this guy in the green shorts. He's looking up, and the angle of elevation is the angle that's formed by that line of sight looking up with the horizontal line. Now, on the other hand, this girl that's over here on the right in pink is showing us what an angle of depression is. So if you are looking down at an object, the angle that your line of sight makes with a horizontal line is called the angle of depression. Let's take a look at an example. You are skiing on a mountain with an altitude of 1,200 meters. The angle of depression is 21 degrees. About how far do you ski down the mountain? Now here, the information is given to you. It says that the angle of depression is 21 degrees. That means as you're looking down, the angle that's formed with that line of sight looking down with the horizontal is a 21-degree angle. Now you're told that the altitude of the mountain is 1,200 meters. Now you're trying to find how far you ski down the mountain, so really you're trying to find the hypotenuse. So look at all the information you have, and again we'll try to determine which ratio to use. Well, in relation to the 21-degree angle, we have the opposite leg, that's the 1,200 meters, and we're trying to find x, which is the hypotenuse of this right triangle. So if we are looking at the opposite leg and the hypotenuse, we want to use sine. So sine of 21 is equal to the opposite leg over the hypotenuse, so that would be 1,200 over x, and we're going to solve for x. So we're going to multiply by x to both sides to get it out of the denominator, and then divide both sides by sine of 21. and sine of 21 comes out to be about 0.3584. So our answer for x is about 3,348.2 meters. So you ski about 3,348 meters down the mountain. Now we've talked about the three different ratios. We talked about tangent last time, and today we talked about sine and cosine, and now we want to come up with a way to remember these trig ratios. Now you can use this to remember the trig ratios. You just really need to remember how to spell it. So it's SOHCAHTOA, and it's SOH, CAH, and TOA. The S, C, and T represent sine, cosine, and tangent. So you can see here that sine, right after that you see opposite and hypotenuse, so that means it's the ratio of the opposite leg divided by the hypotenuse. After cosine we have A and H, which represent the adjacent side and the hypotenuse, and tangent, which is the opposite side over the adjacent side. You'll just need to remember that these are ratios, so these are all opposite over the hypotenuse, adjacent over the hypotenuse, and the opposite over the adjacent. So just so you know, and remember for yourself, H represents the hypotenuse, O the opposite leg, and A the adjacent leg.